Assalamualaikum warahmatullahi wabarakatuh, and hi students. So today we will continue our lesson with initial rate method. In the previous lesson, you have learned about the rate law and what is the rate constant. So rate law relates the concentration of the reactants, the rate constant, and the order of the reaction. And from the previous lesson also, you know that the order of the reaction cannot be determined from the stoichiometrical coefficient. It must be determined experimentally. So today we will learn how to determine the order of the reaction from the experimental data. So look at this example. So consider the reaction A and B converted to product. The results shown below are obtained for the reaction between A and B. So you can see here we have three data. In this table we have a concentration of the reactant A and reactant B, and the initial rate for each experiment. So this experiment is repeated 3 times. So we have these data. Alright, so what is the question? The question is determine the rate law and the rate constant for the reaction by using the experimental data. Alright. So what you are going to do is, firstly, you have to write the general rate law for this reaction, right? With unknown value of order for each reactant. So rate equals to K times the concentration of reactant. So in this case, the reactant is A and we have another one reactant B. So rate equals to K times concentration of A power of X. Let's say the order with respect to reactant A is X times concentration of reactant B power of Y, where Y is the order of the reaction with respect to B. Okay, so actually we are going to determine the value of X and Y, where X and Y are the order of the reaction. Okay, so by using the experimental data, so let's say I want to find X. Okay, to find order with respect to A, okay, which is X. Alright, so in order to determine the X value, we have to choose two data from the table where concentration of B are constant. So in this case, if I want to determine the order of A, so I will choose data from experiment 2 and 1. So we are going to compare the rate. So rate from experiment 2 divide by the rate from experiment 1, which is equals to, so actually this is same with the rate law. So it is equal to K times, okay, so now look at the data for experiment 2. K times concentration of A power of X times concentration of B power of Y, and same goes to for experiment 1 equals to K times concentration of A power of X times concentration of B power of Y. Okay, so now we are going to substitute all the data. Alright, so experiment 2, the initial rate is 1.26 times 10 to the power of negative 2. Divide by rate from experiment 1, which is 8.21 times 10 to the power of negative 3. Okay, equals to K. We don't have the value of rate constant, so just put K here. So concentration of A for experiment 2 is 0.0173 times 0.0713 power of X times the concentration of B. Alright, for experiment 2, 0.0216 power of Y divided by K for experiment 1. Actually, it is same value because it occur at the same temperature. The reaction occur at the same temperature. Okay, so the concentration for A for experiment 1 is 0.0575 power of X times 0.0216 power of Y. Alright, so now you can see we can cancel out the concentration of B and its Y value. Okay, and the rate constant K. Alright, so by using your knowledge in mathematics, the mathematical operation, so solve for this. Suppose you will get around 1.54 and this one is 1.24 power of X. Okay, so solve for X by using log. So this one is log 1.54 equals to X log 1.24, and solve, you will get the X value supposed to be 2. So do not leave your answer with the value of X. You must write therefore or thus A is second order reaction. Alright. Okay, so settle with order with respect to A. Okay, so now we are going to use the same method for to determine the order of reaction for B. Okay, so now look at the data for B. Actually, we are going to compare the rate. So our reference is the general rate law for this reaction with unknown value of order for A and B. Right? Okay, so we are going to compare the rate. In this case, we can use, in order to determine Y, we can use data that has the concentration of A are same. So we can use data from experiment 3 and data from experiment 1. So compare the rate experiment 3 compare with rate from experiment 1. Alright. Okay, so which is equal to K times concentration of A power of X times B concentration of B power of Y. Okay, so now let's substitute the data. Alright, so now look at experiment 3 data for experiment 3, right? Okay, so the initial rate is 1.26 times 10 to the power of negative 2 divided by 8.21 times 10 to the power of negative 3 is equals to K. The concentration of A for experiment A is 0.0575 power of X times concentration of B 0.0333 power of Y divided by K times concentration of A from data experiment 1. Alright, okay, so here is 0.0575 power of X. Here is 0.0216 power of Y. Okay, so for X. Alright, so you will get here from comparing the rate, you will get suppose around 1.53. So this one is cancelled out. cancel out. So solve for this one. Okay, 1.54 power of y. So solve for x. Suppose you will get the y value. Y value is, please use your calculator, 0.98. So 0.98 is approximately to 1. Plus B is first order reaction. Since the question asks you to determine the rate law, you have to substitute the value of order for each reactant into this equation. Therefore, rate equals to K times concentration of A. So just now we have determined the order with respect to A is 2, and for B it is first order. So for first order, you don't have to put power of 1 here. It is understood that this is first order. So this is the first question. Alright, so settle with the rate law. So now we are going to determine the rate constant. Okay, we are going to determine the rate constant, which is K. So since we already know the order with respect to each reactants, so now we can use any data from this experiment, from these 3 experiments, to calculate the rate constant. So let's say I want to use data from experiment 1. So from the rate law, rate equals to K times concentration of A power of 2, and B is the first order. So initial rate for experiment 1 is 8.21 times 10 to the power of negative 3 equals to K times concentration of A here is 0.0575 power of 2 times B, 0.0216. Okay, so now let's calculate the value of the rate constant. We are going to calculate the rate constant. So I suggest to you to substitute this data with their respective unit. So 8.21 times 10 to the power of negative 3 molar per second equals to K. So this is the concentration of M. So M power of 2, and this one is the concentration of B. The unit is molar, right? So molar. Alright, so you can see molar and molar is cancelled out. So leave molar squared and per second. Thus, when you solve this question, you will get the K value is 114.96, and the unit is, right, molar power of negative 2 per second. Okay, class. So that's all for this lesson. Thank you.